In this, I will present a very unique construction of a metro bridge in Pune, where the steel bridge has been constructed. And one important aspect of this bridge is that, so whenever we do some infrastructure works or any bridge constructions, there are hardly anybody thinks or anybody think how it can be constructed. So this is a typical example of such project. The uniqueness of this project is that during design stage, earlier, during design stage, where is the remote? If you can give it to me, it's better. So, slide more. So in this, there are, is there? This one? No, I want to first one. First slide, yeah. Okay. So if you see here, this is a typical plan of the location where there are 4 bridges. Already there are 4 bridges. That is the first one is the first bridge number 1, and there is a stone arch bridge. There is one heritage bridge, and there is a in between these 2 bridges, the present bridge is coming. That is metro bridge. It is to be constructed between the 2 bridges. So there is no chance how to crane is to be taken there or what are the methods to be adopted. And further to add to that, the bridge is designed as a simply supported bridge. Means simply supported means every pier will have an expansion joint. Means each unit is cast in between these piers. So there is no chance to take any construction material, construction equipment on the bridges, because all bridges are load carrying capacity bridges and the arch bridges. So for this, what we have proposed is the incremental launching system. In incremental launching system, what we do in bridge construction, this is a typical site of this location. You can see that the pier is coming from the in between 2 bridges. Why it is running? You can see here the bridge location is in between existing bridge. So over this we have to construct the bridge. So for this, what we have done, entire bridge, what is to be constructed in between, the cross section is having these 4 girders of per span. So in this we have made 2 girders each as a single unit, and they have been constructed or erected behind the abutment or behind the rear span. And you can see that is a runner member, that is an extra member we have given below the flange. And over this member, you can see here, the bridge is erected outside the main portion and it has been rolled into the main portion. So in this, we have used the cantilever nose and winch machine and the Hillman rollers, so that entire unit, after connecting to each other, so it will become a single unit, and we can do the incremental launching. So it is a unique method, or it's a very special method where the construction is such that the river will not be disturbed, or there is no any staging or supporting required from the river portion where we can use for the construction. With this, we have moved the entire structure by connecting 2 of the spans, one to each other. We have moved the, and for this we have used, these are the Hillman rollers. Means over this roller, our entire structure is rolling. And while rolling, we have done some of the stay rollers, so that the entire structure will not move away from the lateral direction. So this is the method we have used. You can see here, these are the Hillman rollers, and over these rollers, entire bridge may move. And at the beginning, the length of the bridge is around 45 meter each span. So we have assembled 45 plus 45, 90 meter and 20 meter launching nose. And after launching that 2 span in the 2 respective span, and we have attached another 2 spans for the next span girders. And they have been again moved further. And here you can see these are the guide rollers. So with these rollers, the bridge has been controlled, or we have controlled the lateral movement of this entire structure. and the entire load of this structure was around 480 ton. So that much of load we have moved it with the winch machine with a number of pulley sleeves. So this is the typical methodology we have used. First, we have assembled two girders, and that green portion is a temporary splice, so that the bridge design is a simply supported. But for launching, we want it's a continuous structure for the launching purpose. And the red one is the launching nose. It is called as cantilever nose, because to make the cantilever arm lesser safe for bending moment. So you can see here, this girder is being launched on the further pier. So these are the stages. So we have analyzed these entire structures for every 1 meter. So for every 1 meter, the bending moment and shear force diagram will change. And accordingly, the front support will get the maximum result, and front tip will get the maximum deflection. So for every 1 meter, we have analyzed in the STAT model, and every stage has been confirmed. And you can see here, during launching also, we have confirmed that whatever deflection we are getting at point number 2 and whatever maximum reaction getting at point number 1, they have confirmed with the all design stages during the execution. And further, we have confirmed with the surveyor. There was a surveyor during entire stage of launching, and the expected deflection was around 25 mm, and what we got is around 12 to 13 mm deflection we got during the maximum load condition. So after this second stage, we have included another 2 span behind the main span. So like this, we have made the entire unit, and we have moved it further to the final position. So this is the very unique method of construction, but this method I think is not considered during the design stage. So hence we have adopted this type of methodology for the metro train portion. So these are some of the detailing arrangements we have done for the pulling of the structures. And another important is, this is the horizontal load or the diversion pulley we have attached to the front pier. And here also we have cross-checked the entire design methodology with the main designer, that is Shirish Patel and consultants. We have confirmed the main permanent design with them also as per the temporary loadings. So with this, I would like to conclude the presentation here only.